Okay, make sure you have your calculators out because obviously we're going to need them. So I'm going to open up mine too. Hello? Yeah, there you go. No, I said there wasn't one. Okay, so modeling a situation with a quadratic equation. Some problems in mathematics can be solved by the following procedure: introducing a variable to represent an unknown value, form a quadratic equation, solve the quadratic equation, then state the solution. So this is like, remember last year in systems when you had to create the equation and then solve for the intersection point. In the same way, we might have to make the equation and solve for whatever the application is asking for. So let's look at a question here. A paved walkway from the main school building to the phys ed block at a school is L-shaped. So it's L-shaped. Okay. With the total distance being 230. So that means this total distance, if I were to walk from here to here, would be 230. That full distance. Okay. A student taking a shortcut diagonally, Dean, God, he doesn't want to be late for class, across the grass, he can walk it in 170 meters. Smart man. It's a triangle. Specifically, what type of triangle? A right angle triangle. Okay. We'll probably have to use that formula. Pythagorean Theorem. If one of the L-shaped sides has a length of x, state the length of the other side. So if this is x, the other side in terms of x, so not with you introducing a new variable, how could we represent the other side? No. 230 minus x. Because we know the total distance is 230. The total distance is 230, so this would be 230 minus x. Okay, so now we can use Pythagorean theorem to make a relationship. So what would it look like? So c squared equals a squared plus b squared. So what's our c value? What is c? No, we know c. Remember, it's always opposite the right angle. So 170 squared. Which one would be a? Does it matter? No, so which one do you want? Yeah, only c really. C has to be the longest side. So 230 minus x squared plus x squared. Right, the two other sides squared. Okay, so we need to solve this quadratic equation. And we know how to solve quadratic equations. Right? We have to get them looking like this. 0 equals ax squared plus bx plus c. Then we can factor. So we need to expand this thing, simplify it, so we can make it look like that. And then factor and solve, or use a quadratic formula if we have to. Okay? All right, so what is 270 squared? So this is where your calculators are important. 170 squared, yeah. 170 squared. 170 times 170. So that's why I asked you to do your 28,900. Okay, what are we going to have to do with this bucko over here? Boil it. Cha-ching. Why? Because he's a binomial. He plays by his own rules. Okay. So 230. Oh, I have an awesome joke. Story for you guys today. Oh, darn it, I ruined it. Okay, I'll tell you later. I got this awesome story that happened to me. No, it's not a joke. It actually happened to me. I'll just tell you after. Okay, well, I rear-ended somebody. Rear-ended somebody? Yeah. And And you know you're like really nervous for somebody, like you never know what when they get out, like are they gonna be like a big guy? Are they gonna be angry? Are they gonna beat on me? These things go through your head. So yeah. So I'm like nervous and I getting my stuff and I get out and the door opens and like you're in kind of the suspense, like what's gonna walk out? And like the last thing you expect was it was a small person, a dwarf. Okay. So then he walks over and I was like, hi, sir. He's like, I am not happy. And so I said, which one are you? It's a joke. It's not really. No, it didn't really happen. Get it? To get it? I am not happy. Which one are you? The 7 dwarfs, you know? No, it never actually happened. Okay, back to the math. Same one? Aww. We use the same material. Okay. Oh, darn it. Funny, though, the first time you hear it. No? Okay. Okay, question, who told it better? Did she tell it better? It's okay, you could tell me. Oh. Oh, you guys heard, you all heard it? Oh. Okay, right. Okay. Darn it. I know, hey? We both. Okay, 230 times 230. 52,900. Okay, 230 times x. Sorry, positive or negative here? Negative 230x. How about the next guy? Negative x times 230. Negative 230x. And negative x times, negative x? Negative x squared. Oh, good job. 2 negatives, positive x squared. And then we also have plus x squared on the back. We can.
Now it's 2x squared.
2x squared. Because like this is the coefficient is 1, right? So we leave, when we add them, we leave the same variable. Then if we multiply, it becomes x to the 4. But we're adding. You're thinking multiply. So 2x squared, negative 230 plus negative 230. Negative 460x. And then we have a positive 52,900. There you go. So whenever we have an x squared and we want to solve an x squared, we always have to get everything to one side and set other side 0. So who we have to move? The 28,900, right? We're going to subtract them to both sides. So 0 equals 2x squared. All right, minus 460. And now we have to type in 52,900. We want to take away 28,900. So 52 minus 28. 52 minus 28. 24? 24? I think that's right. Yeah, 24. 24,000. Okay, so now we want to factor. So first question we ask ourselves, is there a greatest common factor? Look at the coefficients. 2, 460, 24,000. 2, we can divide everybody by 2, which makes me very happy because then we're going to have a simple trinomial. Simples are a lot easier. So factoring out 2, we have x squared. What's 460 divided by 2? 230. And plus 12,000. Okay, so if it's a simple trinomial, we just need 2 numbers that multiply to 12,000 and adds to Negative 230. Well, might be. I don't think so. No, I don't know it. Well, think about it this way. That help? No?
23 is 1200. It's pretty big. I can't. You can just go with the answer. How would you actually do that? There's like.
Well, I would start at like tens. Like, or 100, okay? So let's start with 100. 100 and 120. We're getting close, right? What do we know about both numbers? They both have to be negative because we're multiplying to a negative and multiplying to a positive, adding to a negative. So they both have to be negative. So we're basically like we're adding them together. Okay? So 120 and 100 is not it. So you could go down the list and keep going. But you could also think of 12s. Think of 12s. So 30s, 40s, right? It's very close to that. You find it? So you try 20. Okay, is that going to be big? That's too big, right? So we can try 40. So think of the number 12 to help you out. Try 60. 60 and 200. Are we getting close? Kinda. So how about, what's another one we could try? We did 20, 40, 60. So you try 80. 80 and 150. Does that add to 230? Yeah. So I'm not going to give you something so, like, think of the number that's in front, the 12, if it's like that. And go from there. Okay, so 80 and negative 80, negative 150. So if we go straight to factoring this, how would you write that? Because it's simple. No need the x squared anymore. X minus 80. And no x needed there, right? X minus 150. So what's our solution? X equals 80 or 150. 80 or 150. So the reason why is it 80, or if one of them is 80, then the other would be 150. If one's 150, the other's 80. Right? So therefore, one leg is 80, and the other one was 230 minus 80. What's 230 minus 80? 150, right? And the other is 150. Graphically, right? So once you get to this part right here, we graph it and solve for our zeros. That's the other way. So we plug in, we still have to simplify all this. Actually, you could even go up to here. Very easy. Let's grab your calculators. I'm going to show you another way. Right at the beginning, we could actually sub in two different equations. So let me show you. Y equals. So we plug in one side of the equation. We plug in the other side of the equation. And then we find the intersection points. So 170 squared. And the other side was 230 minus x squared plus x squared. Now obviously, we're going to have to go remember this 170 squared was 28,900. So we need to go really high in this function. What? Go by the millions. Or at least by the 100,000s, right? Because if you graph this right off the bottom, zoom 6, you won't see anything. So let's go to our windows. So you need to at least go to the 100,000s. X, I'm not sure how big we need to go. These numbers are smaller. 230 minus x and x, I'd start with 300. So 300 for x, scale of 10 maybe. And y, 0 to, we need to go at least to 30,000. So maybe we'll go a little higher, 40,000. Go up by the thousands. Graph it. So, you see, did you need help with the window again? Do you need to go back? Okay. So I looked at my x values. My x value at 230 minus x. I thought, okay, probably we're going to use that number. And then this one represents our y, 28,900. So I went up to 40,000. Okay. And then now we're going to find the intersection point. How do we find intersection points? Not zeros. Second trace. Nope. Nope. Because we have two y's, number 5 for intersection. Graph. Second trace, 5. You have to scroll over to the one you want. So I'm already over here. Enter, enter, enter. X equals 150. Second trace, 5. Scroll over to the other one. Push enter 3 times. And there's 80. So 80 and 150. You don't understand? Okay, what part can I help you with? Okay, let me see. Do you have both equations in? You didn't have brackets around this. So this had to have a bracket there and a bracket there. There you go. Yeah. Unless I say specifically how you have to solve for it, you can. You just have to write out what you're doing on your calculator to solve it. Okay? Okay, let's look at another question. Got it now? Okay. Last year, a theater company had 700 season tickets holders. The manager of the theater company has decided to raise the price of a package for the new season to create more revenue. What happens when you raise prices, though? People stop buying. Not as many people will buy, right? We see this all the time in business. And so one very popular problem is we want to maximize profits, right? So we want to maximize profits. So how do we do that? But what should we set our price at so we can maximize the profits? Because you're going to lose people the more you add. And even not Beefus, Boonstra was asking me a max problem. He should set his price for something too. And so that's a very common problem. So here's the problem. The existing cost is $140. Okay? Before raising the price of the package, he hired a market research company to gather data on the proposed increase. The research said that for every $5 in price that they increase, they're going to lose 20 season ticket holders. Okay? So the manager decides that the price increase should be multiples of 5. And so what should we set it up? So 1 multiple of 5, should I increase it with 2 multiples of 5 would be $10. 3 multiples of 5 would be $15. So let's complete the following table. So let's generate some data. So if we increase 1, number of increases was 1, what would be the new cost of the tickets? 145. So we add 5. So it was 145, 140 plus 5 times 1. Okay. And so the number of season ticket holders, we had initially how many season ticket holders? 700 and 720? So how many would we lose? 20 times 1. So we'd have 700. So now what would be my revenue? How would you get your revenue? Right, so the cost per ticket times the number of people. So revenue is always equal to the cost times the number. Right? Cost for 1 times the number you sold. So 145 times 700, what would that give us? Right? Okay, that seems right. Okay, so now we have 2 increments. What would be the new price? 150. So 140 plus 5 times 2. 2 increases. And how many people would we now have? 680, which would be 720 minus 20 times 2. So minus 40. Okay, so what would be the new price? New profit. So multiply those together. 102,000? Agreed? Yeah, okay. So then now, if we did 5 increases, so what would be, if we do 5 increases, how much are they raising the price? $25. So it would be the 140 plus 5 times 5, or plus 25 would give you $165. So then how many people would they lose? 100, 20 times 5. So 720 minus 20 times 5, or minus the 100, would give you 620. 620 times 165. 102,300. Did we skip some here? We skipped 3 and 4. Are we still making more money? Yeah, so we know it's going to be high. It's at least 5 increments or higher. So there's a number of increases. Okay, 10. If we increase it by 10 increments of 5, how much dollars are we increasing? $50. So 140 plus the 5 times 10, or the 50. The price is now 190. And then how many people would you lose? 7. Well, we lose 20 for every increment. So how many, if you do 10 increments, how many people are you losing? 200. 20 times 10. So that gives us 520. 20 times 190. 8,800. So if we went back down, so we know it's somewhere between 5 and 10, right? Because we were increasing, now we're back down. So our maximum profit is going to be somewhere between 5 and 10 increments. So we could keep going and use this guess and check mentality. We can also solve it algebraically. So if we had x increases, well, how would you represent x increase for your cost? So 140 plus 5x. $5 times x amount of increases. And how would we represent the number of people we'd lose? Or total number of people who'd buy, actually. 720 minus 20x. 20 people per increment we lose. And so the revenue, what would the revenue be? Remember, our revenue is this times this. Our cost times the number of people who buy. So our revenue would be equal to 140 plus 5x times 720 minus 20x. Yeah. Oh, it totally is. Well, for business, right? Okay, so write the quadratic function in the form ax squared plus bx plus c. So what do we have to do that? Our revenue is foil it. Okay, why don't you foil this? Go ahead and ruin it. To foil it? No. Get it? You guys never caught my joke. So go ahead and ruin it, because you're going to foil it. Foil it. Foiling it. You've been foiled. You're ruining it. Yes. Yeah, go ahead and...
My baked potato.
Okay. Okay, Dean. So I want you to foil this on your own. Make sure you can foil this out. Okay, so what did you get when you went 140 times 720? 100,800. Okay, then 140 times negative 20? Negative 2,800 x. And 5 times 720? 3,600. And 5 times negative 20? Negative 100 x squared. So collecting like terms, revenue is, you usually put the x squared first, so we should rearrange it. Negative 100x squared. What's 2800, negative 2800 plus 3600? Plus 800. We just write the x squared in the front. Right? Then the x. These are the like terms. 5 times negative 20. Okay. And then plus 100,000 and 800. Okay, so there's our equation. So what is, let's review. What does x represent? What do x represent in our formula? The number of $5 increases. The number of $5 increases. So x was a number of $5 increases. Okay, so write a quadratic equation which could be solved. Determine the number of $5 increases. But that's just for, we're not done yet. There's more on the next page.
Wait, what? Well, that was answer for you.
Yes.
You don't have to figure this from a factor or anything?
You know what? To solve these ones, because it's a max problem, right? We want to maximize revenue. If I graph this and I have a curve, oops. If I graph this and I have a curve, which part, if we want to maximize revenue, and this is revenue, and this is the number of $5 increases. We want to be at the top. So we're going to, what do we call that? Vertex. We're going to solve for the vertex, because the vertex gives us our maximum revenue. So we're going to actually use our calculators and solve for our vertex. Okay, or we can factor it. If we figure out our zeros, remember our vertex is always halfway through. So we can figure out our zeros and then average them to get what's the middle part to figure out how many x increases we should be. So there's two ways we can solve that. Okay? So the next part is just saying, if our revenue is 102,000, what would our equation look like? Would that sub in for x or for revenue? For revenue. So that would just be 102,000 equals our equation. Negative 100x squared plus 800x plus 100,800. Okay? Okay, so D, we just have to finish this question and then we're done. Okay? So turning over the page, it actually wants us to solve this. So we're going to write this again on the next page. Yeah, this question, like as in this question. Okay, so this formula here, can you write it again? Because they want us to solve it. It's the exact same formula. We're going to solve it. We're going to talk kind of. It's one way. I'm going to show you both. So first, without the calculator, how would you solve a quadratic equation? Because you need to know how to do that. Set everything one side to 0. So we'd move who? Minus this guy. To both sides. So 0 equals negative 100x squared plus 800x minus 1200. What can we factor out of this guy? 100. And also, what else should we factor out? If this is a negative, we're going to factor out negative 100. So factoring out a negative 100, which is awesome because it's going to make it simple. So if we divide this guy by negative 100, what is he? Just 1x squared. What's 800 divided by negative 100? We're factoring negative 8x, right? So you could also write divided by negative 100, divided by negative 100, divided by negative 100. And what's negative 1200 divided by negative 100? Plus 12. Is that guy easy to factor? Yeah, two numbers that multiply to 12 add to negative 8. Positive or negative? Negative 6, negative 2. Negative 6, negative 2. Okay, so how do we write that inside? X minus 6 and x minus 2. So what is our solution? X equals 2 or 6. So you can have either 2 increases or 6 increases would give you the exact same revenue. Exactly. So if you were a businessman, you might think, oh, I might want more because of, right? But we actually want to maximize. So there's one number that will maximize it, and that's probably going to be our best bet. Now this also tells us where our maximum should be. Because if this is halfway, if these are the exact same, remember our curve is symmetrical. So what's halfway between 2 and 6? 4. How do you get halfway between two numbers? Add them together and divide by 2. So we know 4 increases actually should be our best, right? Because our graph is symmetrical. So 2 increases or 6 increases will give you that revenue of 102,000. Okay, so determine the cost and the number of, so if it was 2 increases versus 6, how much would basically we want to know what would the cost of the price be and how many people would we have. So for 2 increases, what would be the new cost? $150, because we add $5 to the 140 for each, right? So 2 increases. How many people would we have? Remember, we started at 720. So we're minus 20 from each one. So that would be 680. How about 6 increases? So our cost was 140 plus 5 times 6, 30, so 170. And the people, 5 times 6, sorry. Remember that was our formula we came up with in the beginning? Oh, there you go. Slow there. And the people was 720 minus 20 times our x, and our x is 6 here. So 20 times 6, 120, 720 minus 120, 600. Okay. So what these two multiplied together, what would they be? People times cost, what did that equal? Revenue. What was our revenue for both of these? Did we know that already? 102,000. So this times this should be 102,000. This times this should be 102,000. Okay. All right, the vertex. Grab your graphing calculators. Well, if we're looking for the vertex, yes. Depends on what you're solving for. Okay, let's graph our equation for revenue. So our revenue equation was 140 plus 5x times, you're probably going to have a revenue question on your unit exam. Unit exam. Question just like this. Okay, where you have to make the formula yourself. Okay, 170. No, how much? 720. We see we're at 720 minus 20x. Okay, we're graphing revenue against number of increases. X is number of increases. So does X need to go very big? Let's go to our windows. Was our X values very big here? 2 increases, 10 increase? No. So we can go 0 to maybe 20 or 15 or 10, maybe 10. Scale of 1. Was our revenue, did our revenue go very high? Yeah. How high did it go with some of the problems on the previous page? 102,000, right? So we need to go like to 110,000 at least. Maybe even a little higher. Let's go 120. Be bold. Scale of 1,000. So we should be able to see our graph very nicely here. So we use that data we had, X, we're graphing X, number of increases with revenue. Think about what you're graphing here when you make your windows. Yes. So I see what my Y equals. So that was our equation. Remember the equation on the previous page? $140 plus $5 for every increase. Okay, go to Y equals. Okay, that's okay. So we can change this. Our X then, if we graph that and it looks weird, it is curving up, but it looks weird, we can change our X's. No, well, we're really high up. If we change our X scales to negative 100 to 100, see what it looks like now. See? Okay, sorry. Sorry, I need to slow down. I apologize. Okay, so when you graphed and you're like, I can't really see much of a curve, then obviously that our height was okay. We just needed to go longer. We were 0 to 10, so let's change that to negative 100, 100, whatever, negative 50 to 50. Try it out. I guess and check too. You use some logic and some guess and check. Mixed together. It's a really nice combination. Okay? So what's important? If we're graphing revenue with number of increases, what do we want? If you're a business, you want to maximize revenue. You want to maximize your profit. You want that high. You want that guy right up there. So maximum. So second trace, maximum is number 4. We go left of the maximum, enter. Right of the maximum, enter. And then about where is it? It's about over there. 4.0. Isn't that what our guess was? 4 increases? Because it was symmetrical? Yeah. So 4 increases and our profit would be 102,400. So add $20 to every ticket. 4 increases. Okay, so our vertex was 4, 102,400. And so that means we want 4 increases. And our revenue would be this much, $102,400. And so then what should our cost be? Cost was 140 plus 5 times the number of increases. So we're adding $20. 160 bucks should be the price of a ticket. And then we're going to be seeing dollar signs. Yo.
Yo.
Okay, so your homework is the rest of the assignment, 5 to 10.